I'll say thank you for joining us here at ONICON for one of our webinar series here. This one is going to be on the power of the Inline mag, our FT3000 series meter. So today it's going to be hosted by myself, Eugene Sollog. I'm a regional sales manager here at ONICON. Answering questions at the end is going to be Megan Strand, who is the product manager for this product. So she's going to be responsible for a lot of these new features that have been popping up lately. And also Mike Rivers, who is the director of sales and marketing. So we're going to go through 4 main points in this webinar here. First, we're going to look at key features and benefits of the FT3000 series. We're going to look at some of the industry challenges with flow measurement, some of the best practices for installation and integration with this flow meter, and then also applications and real cases that we've seen with this meter. And then at the end, we're going to do a Q&A session. So I'm encouraging you to ask questions whenever. The question box is up in the top right corner of your screen there, so you can ask them at any time during this, and at the end, we'll address all the questions with answers. So with that being said, let's get a little quick overview on who we are if you're not familiar with us. So a little bit about ONICON. We were founded in 1987 in Clearwater, Florida. We quickly shifted focus to the HVAC applications, or HVAC industry. So basically what that means is we primarily serve the HVAC community. So all the applications within that, we have a flow meter for that, basically. In 2019, we became part of TASI Measurement. What that is basically a giant conglomerate of flow meter manufacturers within different industries. So, if you do need those 1s or 2Z meters that are kind of a one-off application, we could probably get something solved for you. So with that being said, on the ONICON side, we do liquid flow, steam flow, gas flow, and BTU measurement. So what makes ONICON different? There's a lot of other manufacturers out there, so how do we separate ourselves from them? So the first thing is we have a bunch of different technologies for all different applications within the HVAC industry. So we don't believe in one size fits all or one technology for every application. We want the right technology in the right application. All of our flow meters are wet calibrated to provide that high-end accuracy that we really need in the HVAC industry. All of our meters are engineered and custom configured to be plug and play out of the box. So we do have an order form. If you've ever ordered from us before, we do ask a lot of questions up front, but that is because we pre-program, build, and calibrate that to your specifications. And we are also known for our customer support. So we have a pretty big team here in-house of all degreed engineers answering the phones for any application help or any tech support help. We also back up our product with a 3-year warranty. And in that 3-year warranty, that first year is no fault. So no matter what happens in that first year, we're going to take care of the meter or whatever happened at no cost. So either fix it or replace it. And like I said earlier, not one size fits all, right? So we have all these different technologies for all the different applications within the HVAC scope. So each one of these boxes is a different technology or a different technology family, we call them. And today we are going to be addressing the FT3000 series Inline mag. So looking at the Electromag family, we have a few different offerings here. So we have the FT3400, which is an insertion mag meter that's blind. Our last flow meter webinar was the FT3500. So if you were present for that, that was the meter we talked about back in June. But today we're going to take a deep dive into the FT3000 series Inline mag. So what what is the mag known for, right? So this is our highest accuracy meter, our most reliable meter, the best straight run requirements out of any one of our flow meters by a lot. And this is really the best choice for those high dollar custody transfers, or when you're trying to protect any critical data, say in a data center or something like that, where there's a massive investment in servers or any other equipment. People trust the inline mag, the FT3000, with that responsibility. So those are some pretty large claims I just made on the inline mag meter. So let's just see how we do that. So the principle of operation, the mag meter uses Faraday's law of induction. So what that is basically when a voltage will be induced in a conductor. In this example, the conductor is water, the fluid in an HVAC system. When it passes through a magnetic field, which we are creating with our flow meter, right? That voltage is directly proportional to the velocity of that conductor, the water in the pipe. This voltage is then measured by some big electrodes that we have on the sides of the meter, on the inside, on the opposite sides of the flow tube, and that's used to calculate the flow velocity. So we're measuring flow velocity with this meter. The polarity of that voltage signal is directly related to the direction in which the conductor moves through the magnetic field. So this meter, by nature, is a bidirectional meter, just like both of our insertion mag meters. So taking a look at this cross-sectional cutout of what the meter actually looks like. So there's a large coil on the top and a large coil on the bottom of our flow meter, and two giant stainless steel electrodes on each side. So what we're able to do is create a very large, very uniform magnetic field through the whole cross-sectional area of that flow tube. So if you look at the diagram there, you can see big 316 stainless steel electrodes. We have a stainless steel flow tube, 316 stainless steel flow tube. You might see that on a spec every once in a while where it says in an inline mag spec where it has a stainless steel flow tube. That's what it's referring to. It doesn't necessarily mean it's a stainless steel bodied meter, just the flow tube that's the inside is that stainless steel. And of course the liners on the inside there. But also how this works is we are capturing the whole cross-sectional area of that water flow. So we're able to control the flow through our meter, which makes it extremely accurate and reliable. So like I said, again, highly accurate across a wide turn down. This will go up to about 33 feet per second, as we'll look into when we deep dive into the transmitter. But wide turn down, minimum straight run required. So to meet our accuracy statement, you only need 5 total pipe diameters. That's 3 upstream of the meter and 2 downstream of the meter. And if you can see that picture on the lower right-hand corner, it is measured from the center point of that flow meter. So when you think about it, even the small flow meters, the meter body might be pretty close to what your straight run requirements are. Also, a new feature for the inline mag is a 0 straight run requirement, and we have still better than plus or minus 5% of rate accuracy when installed directly between 2 elbows. So exactly like that picture there, without that straight run. The inline mag is also ideal because it is unaffected by water quality issues such as scale and any kind of debris found in open loop water systems. So makes it ideal for any kind of who knows what's flowing through these pipes. We've seen some crazy things over here. Like I talked about with the nature of the technology, this is a bidirectional flow meter. So this is also ideal for those bypass lines, especially when there's not a lot of straight run usually available in the bypass line. Every one of our flow meters at ONICON is individually wet calibrated with that certificate of calibration. So what that means is we actually have this in a pipe and there's water being flowed through this flow tube to get that calibration factor. So everything is individually wet calibrated to the highest standard. And then here at ONICON, we also factory program everything to your specifications. So no matter what you put in that, not no matter what, but most things that you can put in that order form, we will pre-program that flow meter to your specifications. Now to kind of look at a deep dive into the two different versions of the transmitters we have for the inline mag. The FT3200 series, as we call it, is our Cadillac version of the transmitter for this inline mag. It is plus or minus 0.2% of reading accuracy from 1.6 to 33 feet per second. And to highlight some of the features, the optional output signals, we have multiple analog output signals. We have 3 pulse inputs and outputs. We have a brand new feature called built-in verification. We have the brand new BACnet RS485, and we have MODBUS RS485, which is MODBUS RTU, and also TCP IP available. We have 2 different power supplies that we could use in this, so 24 volt AC or DC, and also the high voltage version, 120 to 240. Another option with both these transmitters is the remote mount housing. So we could have this mounted straight on the meter, like in the previous pictures, or we could have this remote mounted somewhere else in your mechanical space. So with this one, 3200 being a more powerful and accurate transmitter, this can actually go to runs of 200 feet away from that flow meter body. We can go further, but we need to add a signal amplifier. Another thing I want to mention about the remote mount cable is a lot of the times we'll have a customer that orders it for, say, 50 feet, but they only needed 25 feet away. Instead of cutting that cable, because this is a very special cable that is very sensitive, and we're picking up these small voltages within the meter body, right? That we suggest it to be coiled up and put in a separate junction box. We do not recommend cutting it in any way. That will void the warranty on that cable. So looking at the FT3100 series, this is our basic standard transmitter, plus or minus 0.4% of reading accuracy, up to 33 feet per second, just like the 32, but it starts at 3.3 feet per second, all the way down to 33 feet per second. There are no optional outputs with this. It is what it is. It's a low voltage only version. This can be remote mounted, but this being a less powerful transmitter, we can only go up to runs of 100 foot away from the flow meter body. After that, we could also add the amplifier to this as well. So to kind of jump into some of the challenges that we see with flow measurement. I know that sometimes you'll get into a mechanical space and you'll see something that looks like that on the picture on the right, and you don't know where to put the flow meter. The inline mag is by far the best choice as of a flow meter to put in something that looks like that, but it's still, could be very costly to put that in. So we're going to kind of go in and look at where our thinking is with certain different with these flow meters and other flow meters. So kind of a motto here at ONICON is this quote from Lord Kelvin: "If you cannot measure it, you cannot improve it." So we're always looking to improve the efficiency of our systems. We always strive to make our systems more efficient, not just to save money, but for also the reduced emissions. So certain trends that we're seeing that's driving the need for flow measurement, you can kind of break this slide down to 3 basic points: measuring, controlling, and billing. So measuring, just getting a flow meter in, seeing what's happening in your system, see what's going where, what your loads possibly are. Controlling, staging chillers, staging boilers, etc. Trying to get those control strategies to get an efficient energy plant. And then billing is another big one that we're seeing more often. And this is even down to the tenant level. So you could have individual tenants and put like a flow meter or BTU meter on each one of these, and billing based off of actual usage on the BTU side. And to kind of look at, turn down. So every flow meter is going to have a specific turn down, right? So this one is up to 33 feet per second. from, just about 1 foot per second to 33 feet per second. That's all well and good, but except for our industry in HVAC, we are going to be looking at the effective turn down. So that's what we find important. If you look at this velocity table, which is very handy, we're typically flowing in the HVAC industry around that 4 to 8 feet per second, which is kind of the sweet spot for heat transfer as far as water flow goes. As you get too fast, it's going to cause too much noise, and not enough heat transfer is going to take place, and it's going to be just inefficient in that way. So we're actually operating at the lower end capability of a flow meter, especially this one, right? This one tops out at 33 feet per second, but we're seeing mostly on that lower end. So the accuracy statement is very critical when we're looking at it this way. That's why all of our meters are wet calibrated. We need to put them in the pipe, flow the water through it that they're going to see in the real world around that 4 to 8 feet per second, and get that fine-tune the accuracy to make sure that we are reading correctly. With that being said, can't talk about accuracy without straight run requirements. I know it seems like, this is what we would love to see all the time at ONICON. This makes our lives very easy. But we get to the mechanical space and we see something like this, which is very hard to get a flow meter in to read accurately. Oops, sorry, I clicked out of that. And just to kind of look at a single 90, for example, you can see all the swirl that's induced in this. Ideally, we'd always like a symmetrical velocity profile for our meters, or any meter, really. Any meter manufacturer would want to see that. Luckily, we have other technologies like the Inline mag, which could compensate for this, because it averages the flow through the whole cross-sectional area a lot better than any other flow meter really can. These are just some CFD models that we have that show a multiple bend out of plane. So you can see the swirl that's induced in this. It really causes a lot of swirl in the pipe, and it's hard for any flow meter to really read. So straight run requirements, just as a rule of thumb, we kind of always want to be away from control valves, inflowing tees, multiple bends in and out of plane. Outflowing tees, pipe reduction or enlargement, and single bends are easily workable, especially with this inline mag meter. So talking about straight run requirements, so this is our new certification. Nothing was changed on the meter. It always performed this way, but we actually sent it out, got it certified according to ISO 4064 standards to be better than plus or minus 5% of reading accuracy between two elbows. So 0 straight run, 2 elbows, and you can see the test results there in that table. It looks like the worst that we were was negative 0.29% error at just over 1/10 of a foot per second. Also with this meter, looking at the different install requirements, this meter is available in a threaded version. You can see the picture is the flange, but we have a threaded version from 1/4 inch to 1 inch. We also have the ANSI 150 and 300 pound flanges from 1 inch to 48 inch. This is typically what we're going to be seeing is 150 pound flanges in the HVAC industry. We do see some 300 pound flanges in those high rises like in New York and Chicago. We also have 3 different liner options with this. All of them are NSF 61 certified. We have ebonite, polypropylene, and PTFE. Ebonite and polypropylene are typically what we're going to be seeing for your chilled water, domestic water, condenser water, just regular water with mild additives could be in there, like any kind of glycol. It doesn't really care about that. But the cooler temperatures for ebonite below 175 and for polypropylene below that 140. With PTFE, that's what we're going to always use for heating hot water, domestic hot water, and any kind of chemical additives or abrasive additives. We're going to want that PTFE liner in that. That's to include, brine or any kind of salt or seawater that might be coming in. When talking about installation with these meters, grounding is critical for any and all electromag meters. This is our insertion meters as well as our inline mag meters. It's a little bit easier with our mag meters to ground. So this is an example of a conductive pipe. So this is your coppers, your steels. We still need the flanges to be bonded together. So we do require it to be drilled and tapped on the pipe flange, and we have the lugs, grounding lugs, on our flanges. The reason for this is the bolts going through are not a very good conduit for a ground because our meters have a thick epoxy coating on them, which does not always scratch off or conduct very well. So we do need those bonding points in the flange, and then taking that to an earth ground is a good, always a great practice in conductive pipe. So for non-conductive pipe, your PVCs, your HDPE pipes, and any other non-conductive pipe, we do require and always recommend the use of grounding rings or grounding probes. Grounding rings typically always are going to be used with the inline mag because they're sandwiched right in between the flanges. What this does is it provides a path for ground for any possible noise or extra electrons able to go through that conduit of the grounding rings and find a path to ground, instead of finding a path to ground through our meter, which could cause some possible interference with that. These meters are picking up these small voltages that it's inducing into the water, so they are sensitive. So looking at some typical applications with this, this can be used in so many different applications, providing the below is fulfilled. Again, we're looking at a conductive fluid moving through a magnetic field, so we need conductive water. It cannot be RO water, DI water, or anything below 5 microsiemens. So that's the minimum conductivity for these meters. The piping system also needs to be full, always a full pipe. We are measuring velocity and calculating the volumetric flow based on that velocity. Not only that, but if it's below one of the electrodes, the meter will go into an error and will not read properly. The fluid temperature and pressure is going to determine the liner and the flange size. So that's also a caveat to always look out for as well. So some of the typical applications we're going to see, obviously we do a lot of chilled water, heating hot water, condenser water, domestic water, and boiler feed water. That's typically what we're going to see in the HVAC industry. Some of the special applications that are the onesie twosies that we get, so irrigation, well, pond water, sea water, if you're close to the ocean at all, pulling that in, and gray water, and could be rainwater that's being collected. Also, with this meter, it can be used in conjunction with one of our BTU meters. So the 3 on the bottom left you're seeing are the System 1000, the System 10, and the System 20. This inline mag meter can be used in conjunction with any one of those flow meters. Just depends on what you need out of outputs from those flow meters. So when we're talking about, billing on a high level for energy plants, you're billing, tens of thousands of, BTUs per day. So you really want that accurate flow measurement system with an accurate BTU meter. And it's good to have it all under one roof. We're taking control of that with one of our BTU meters and our flow meter. Everything is paired and calibrated together here at ONICON. Again, kind of doing a deeper dive into the energy and BTU measurement. So what is this actually giving you, right? So flow meters assist in assessing the energy consumption of different parts of HVAC systems, right? So we want to optimize our chiller plants. We want to optimize all of our systems so that we could, save money, reduce wear and tear on equipment, and et cetera. Water flow measurement, maybe you're not doing BTU and you're just taking, right off of a chiller, but there's no room because you have, like in this picture below, it's coming right out of a chiller to a 90 into one of our flow meters, and it goes right into a pump header. And then after the header, it splits into, 10 different directions. So to get, within that straight run requirements to be able to measure accurately, the inline mag is the ideal choice for, those tight spaces. Now in the data center world, these things are going up, every day. The internet's not slowing down, AI is not slowing down, and it requires more and more data centers to be built. And these data centers are trusting inline mags, the FT3000 series, to deliver accurate and reliable readings to protect their very expensive equipment that they're investing in these data centers. So the inline mag is the ideal choice for this type of application. Time to look at some troubleshooting that we've seen in the past. This is from 2019, so quite a while ago now. This was actually a leak that happened and was not realized because there was no meter on the makeup water. So they were just relying on the city meter to let them know what was going on. Basically, after further review, we found the leak in the rooftop unit fan coil, and chilled water was running down the roof into a drain and into the gutter, basically. So if they had an individual flow meter on that makeup water, they would have understood that they're using too much water in there. Instead, they kind of had to learn the hard way, and then they realized this data after the fact, that their flow meters were trying to tell them something. Another example for some troubleshooting. This was a kind of a recent call from one of our reps. Basically, we have our inline mag. You can see on the picture on the right, the transmitter there was reading about 360 GPM. The test and balance came out, basically thought that they should be seeing about double that, around 700 GPM. So a rep went out there, put their strap-on ultrasonic meter on there, and the values basically corroborated with the inline mag meter. So just as a rule of thumb, taking a DP is going to be typically a percentage of full-scale device. We didn't really dive deep into the accuracy because these inline mag meters are a percentage of reading device, not a percentage of full-scale device. So when looking at these types of installations where you have a bouncer coming out and looking at these, just to kind of keep that in mind, they're not always as accurate, especially when comparing it to a plus or minus 0.2% of reading flow meter. Another new feature, relatively new feature, thanks to one of our talented mechanical engineers here. He has designed these extensive Revit families here that when used, it takes all the guesswork out of any possible, new engineering design drawing. Basically, you just take the Revit family, it'll outline the straight run for you. As you can see on that picture there, the green dotted line is the actual straight run needed for a 10-inch pipe. It gives you all the dimensions of the flow meter, the flange, the liner that you need, and transmitter location. So if you're mounting this remotely, it'll actually, you could break off the transmitter and have it in a remote mount location. So all these Revit families are available on our website under the downloads and under CAD and Revit files. All right, now to kind of wrap this up for the FT3000 series, just some key points I wanted to re-highlight. So this is the highest accuracy meter of anything that we offer. And we kind of went in how that works. We're controlling that whole area, extremely accurate and reliable flow meter, the best straight run out of any flow meter that we offer. down to 0 straight run between two 90-degree elbows. All the new features that we're coming out with constantly to try and make it easier for our integrators to communicate with our flow meter. And by all means, if you have any other new things that you want to get added or see added to our flow meter besides the analog outputs, the RS485 and the IP, please drop that as a question. It's a suggestion. The new built-in verification. So this is an option with our 3200 series transmitter. Basically what that actually does is it keeps a live track of how the meter is doing. It's going to take data from the coils and from the electrodes and from the output. It's going to collect all that data over time, and then basically it'll highlight if something goes awry down the line. It'll highlight that, let you know over the communication to let you know if your meter needs attention. And then again, everything factory programmed the ONICON way. So we do ask a lot of upfront questions on our order form, but that's all to pre-program and make sure that this meter is plug and play out of the box. And again, the little bit of the ONICON philosophy, kind of touched on this a little bit just now. Engineered solutions configured to your specs, NIST traceable calibration standards, all of our flow meters, highly trained application engineers and technical support engineers. So if you can't get a meter working or going within 10 minutes, drop what you're doing, give us a call. We want to help you out. We want to get it working. Not to mention that, we have a rep network all around the world. So find out who your local rep is, get them involved, and they're eager to help. And then we back that all up with our warranty, 3-year manufacturer, and that first year being completely no fault. So no matter what happens during startup, we'll take care of you guys. And that's it. We're going to look at all the questions and get back to you guys in a few. Thank you.
All right, thanks, Gino. Again, thanks for everyone for being here today, joining the webinar. We will spend the next few minutes here answering questions. Had several come in throughout the presentation. As a reminder, you're going to ask questions in the top right of the platform with that question box. So let's see, first question here. What kind of maintenance does the FT3000 require over its life cycle? Megan, would you like to take that one?
Yeah, I can go ahead and answer that. So it's a good question. Maintenance on the FT3000 series is pretty minimal. There's no moving parts within the flow sensor, and so you can expect years of reliable service with very, very little maintenance on this. One thing I do want to highlight is for dirty water applications, the transmitter does have the capability to clean the electrodes. So again, there's no moving parts within the meter itself. There's no electronics, that's touching the water. But if those electrodes do get dirty or have buildup, from the transmitter themselves, you can initiate an electrode cleaning, which helps the longevity of this meter as well.
Thanks, Megan. See, next question. How often do these meters require recalibration? Let's see, Gino, do you want to take that one?
Yeah, sure thing. So there's no standard time frame on recalibration. There's no moving parts of this meter. There's no electronics in the actual flow tube. As we kind of took a look at the cross section of it, it's just basically the coil and the electrodes in there. The built-in verification is going to actually let you know if there is something that could be, used to determine if that meter needs to be serviced. But because all the electronics are in the transmitter, if your meter fails, basically the built-in verification is going to let you know, or you're going to know because there's going to be no output. If you do need to do something as far as recalibration, we kind of recommend doing a verification. get out there, call your rep, throw a clamp-on meter out there, or throw a different meter out there, and check that, just like we did in that example at the end of the presentation with the FP4400.
Thanks, Gino. Yeah, we even see some engineers that will put like a ball valve downstream of an inline mag meter with new construction. Gives you the opportunity to kind of help validate those flow meters, years down the road. All right, next question. Are the meter and transmitters suitable for outdoor applications? Let's see, go back and forth here. Megan, do you want to take that one?
Yeah, I can definitely take that one. So yes, the meter and the transmitter as well, it's rated NEMA 4 for outdoor use. So they can be used outdoors. They're used outdoor all over the world. And one thing I do want to mention is the transmitter also comes with a UV cover that goes basically over the screen. So you can protect your screen from any UV or sun damage as well. So yes, can absolutely be used outdoors.
Thanks, Megan. A lot of good questions coming in here. See, this next one's around remote cabling and what's available from a remote cable length. Gino, do you want to take that one?
Yeah, sure. I think I hit this pretty good in the in the presentation, but so it's a little different, right? We have a low-powered FT3100 version, which is up to 100 feet long, and that starts at increment at 16 foot. So you could have increments of 10 or 20 feet up from 16 feet. And the same thing with the FT3200, except that'll go all the way to 200 feet with the same increments of about 16 feet. If you do need longer, we do have a signal amplifier available that will provide for those longer runs if needed.
Thanks, Gino. Next question here. Well, looking like regarding the stainless steel tube. Sometimes I see on the specification that the meter needs to have a stainless steel tube. What does that mean? Does the full meter need to be stainless? Megan, you want to take that one?
Yeah, I'm glad this question was asked because this comes up a lot. We see this with customers. There's confusion around, does the meter need to be stainless or is it just the tube itself? So, Gino, can you navigate back to, you had a slide, I think it might be slide 11, that showed a good image of kind of the meter deconstructed.
Yeah, no problem.
That's it right there. Perfect. Okay, so what I want to highlight here is, so all of our meters come standard with the two stainless steel electrodes. So you can see those in the center. That's what Gino was highlighting. But they also come standard with a stainless steel meter tube. And sometimes you'll see that on the specs. And then the meter tube is covered inside with the liner material. We offer PTFE, polypropylene, and ebonite. Gino discussed that earlier, depending on your application temperature. But then outside of that meter tube, that stainless steel meter tube, that's where the coils are mounted. And then there is a shroud that comes on the outside. So as I mentioned before, the meter tube itself, which is what could potentially come in contact with the water, is always stainless steel. But for the shroud, which is when you're ordering the meters, you'll notice that you can order in carbon steel or stainless steel. The shroud, what's standard is carbon steel, and that's what we recommend for most of our applications. So if you're working, with chiller plant, data center, even standard outdoor use or indoor use, carbon steel bodies are going to be sufficient for you. When we would recommend stainless, like a stainless steel shroud or outside body, is when you're in a highly corrosive environment. So if you're lucky enough to be working near the beach, that's when we would recommend that stainless steel shroud. So hopefully that answers that question.
Yeah, thanks, Megan. I think we get a lot of requests for stainless steel meters, but in reality, it's a fraction of less than 1% of what we actually sell. It's quite the premium, special ordered meter, and like Megan mentioned, those components touching the water is stainless steel, which is what most people are worried about. Let's see, next question here. So two good questions from Vince from Precise Engineering. The first is around, some owners like to have a bypass installed around their flow meters for any maintenance required. However, with no moving parts, it's hard to imagine what kind of maintenance would be required for an inline mag meter. Do you recommend installing a bypass around these flow meters, and if so, what specific instances and applications? Yeah, this is a great question, and it's probably not super clear answer, so I'll take this one. You know, I would say when we see this, it's a pretty conservative approach to put a bypass around an inline mag. I think, you know, this kind of goes along with how Megan was answering what kind of maintenance is required. And, you know, there's no moving parts, like Vince mentioned there. And so if anything does fail with the meter, it's typically going to be in the transmitter, which can be replaced in the field. So I would say it's not very common, especially in the larger sizes. Maybe the smaller sizes, it's a little bit more cost effective to put a bypass around it if you want to have a conservative approach. Another solution that sometimes we would see is just be conscious of where you're putting the flow meter in some shutoff valves. Is it possible to shut off the valve and remove the meter if you ever needed to? So I would say really, you know, shutoff valves are even more conservative. A bypass is only really for those. We would really only strongly recommend that for those really critical applications. Like, so if you had an application where you go, shutting down the system was not possible and that flow measurement was critical for the operation of that system, I could see a bypass might be required for that type of application. So, no, that wasn't a super clear answer, but hopefully that answered you, Vince. I think you had another question too, so I'll just tailor your, both your questions here. For the grounding, I believe both slides said for non-conductive piping. So are there no requirements for grounding when using conductive piping? Gino, can I actually ask you to go back to those two slides as well? And I'll try to answer that one as you're finding those slides there. So there's two different reasons for grounding the meter. The first slide is around grounding the actual meter to an earth ground, and that's where you see there flanges of a steel pipe going to a ground, and then you're grounding the transmitter to an earth ground. That comment there is around non-conductive pipes is what we try to illustrate on that second pipe. So to kind of recap, you have to ground every meter, even in a steel pipe, both at the transmitter, and if it's in a steel pipe, we ask you to ground the flanges to an earth ground. There's a more grounding that's required with non-conductive pipe, and that's because the pipe wall or the actual pipe acts as more of an insulator to kind of any electrical noise, where in a metallic pipe we kind of find the piping is used almost like an earth ground for that electrical noise. So a non-conductive pipe, we require a little bit more hardware, grounding rings or grounding probes, more commonly grounding rings for an inline mag meter, where you're flanging rings in between the non-metallic flanges, and now you're grounding those earth rings to an earth ground. And so what that is allowing it to do is any of that electrical noise in the pipe, find a way to ground through those grounding rings so you're neutral at the point of measurement. Good question.
Yeah, that was probably, so we have these everywhere in our manual. So I just took a snip out of the manual, and we have this, you know, all over the place for grounding in non-conductive pipe. But this was, yes, you're correct. This says non-conductive pipe here, but it does, you know, there's still grounding required on this, just bonding two flanges together.
Thanks, Gino. All right, next question from Christian. Can you mount in a vertical pipe? Megan, you want to take that one?
Yeah, absolutely. So installation can be done in a vertical pipe. So that's running with flow upward or downward. That is acceptable. One of the big things that we ask for, though, is provided that the system is pressurized, so a closed loop system. when you're running in a vertical pipe with a downward flow, if you're discharging to the atmosphere, we do not recommend that type. So for closed loop systems, yes, they can be installed vertical, but if you do have a discharge that opens up to the atmosphere, we do not recommend that for these meters.
Thanks, Megan. Next question, can we use this model to measure condensate? I'll take this one as well. So thanks, William. That's another good question. And so the requirement on this meter is 5 microsiemens. And that's with an integral version. A remote transmitter actually might be a little bit more than 5 microsiemens. And so we use this meter for steam condensate, but you want to be conscious of what the connectivity is for that application. You know, in most applications, steam condensate is going into a tank and sitting there picking up elements where that connectivity is going to be over that threshold. However, we have seen over the years a few instances where that conductivity of steam condensate is more pure than 5 microsiemens. So I think that's just something you want to be conscious of. If there's ways that, you know, test your connectivity beforehand, that would be helpful. If you are in an instance where you believe your conductivity could be below that 5 microsiemens threshold, we have other technologies that would be suitable for that. Our single insertion turbine can be modified to read down to like 1 or 2 microsiemens. We've also used vortex meters for no conductivity applications. And I would say probably our most common would be an ultrasonic technology to measure no conductivity. Good question. Let's see, next question from Ali. Is it recommended to install valves on either side of the unit for a replacement? Yeah, that's a good question. I think I probably answered that one already. I don't know if you guys wanted to add anything to that.
No, if I could drive anything home about that, it's just that these meters do typically have very, very little issues, you know, in the field with the flow. And so it's not required that you install it. And I know for budget-wise, it adds to the budget. So it's pretty uncommon that's going to be required for these meters. Yeah,
thanks, Megan. I think the question probably came in before I answered it there. It comes back to the application too. You know, it's if you have a critical application and you want to have a more conservative approach, we do see engineers installing valves on both sides, like shut-off valves, but I would say more commonly because of cost, no maintenance inside the meter, it's not as common. All right, next question here. How are the flow meters affected by air presence in the line? I might take a stab at that. I'll let you guys fill in if any gaps here. So, you know, I think we do, like we mentioned, these do need to be installed in an application where it's full and pressurized. However, even in full and pressurized pipes, you could find some instances where you have micro bubbles. So I'm assuming this is not in regard to a non-full pipe, but more around like a micro bubble situation. And so, you know, when we install the orientation of the flow meter, I don't think they actually had a diagram in this presentation, but it's in our manual. Like when we install it, we recommend where the transmitter is either at 12 o'clock or 6 o'clock, and not making these at an angle. And the reason for that is because the stainless steel electrodes, we want them to be at 3 o'clock and 9 o'clock. And we find if you had it rotated at 12 o'clock and 6 o'clock, you know, there could be sediments built up over time, and you could have micro bubbles on those electrodes at that time. But we have found in, you know, most applications with micro bubbles being present, since these electrodes are at 3 o'clock and 9 o'clock, you're not going to have an effect on that measurement. Now, again, if this is a non-pressurized system, or like how Megan was mentioning in a vertical pipe going down to atmosphere, or that's a different type of bubbles, and we do want to stay away from non-pressurized systems. Yeah, good question, Arun. Okay, I think that's the rest of our questions. If you have any other questions, Gino mentioned this, but we have a great rep network globally now around the world. So feel free to reach out to your local rep or call our sales office. Reach out to ONICON, or you can reach us at sales@ONICON as well. Happy to answer any additional questions you may have. But so it looks like we still had a large group here. Again, thank you for the time, and please look out for us for the next webinar here coming up in the next month or two. Thanks, everybody.